You talk to your phone all the time, right? You ask it for directions, you tell it to play a song, but have you ever stopped and wondered how it goes from just hearing, well, noise, to actually understanding what you want? Let's get into it.
It really does feel like magic. You say something and poof, an answer disappears. But it's not magic at all. It's actually this incredible process of turning physics into data, and then turning that data into actual meaning.
You know, the best way to wrap your head around this is to think of your phone's AI like a super attentive friend, a friend who's listened to like millions of hours of conversations. It's not thinking like we do, it's just gotten incredibly good at recognizing patterns and making a really educated guess about what you're trying to say.
So before any of that smart AI stuff gets involved, your phone has to solve a pretty basic physics problem. How does it even capture the sound of your voice? This first step is all about translating the real world into the digital world.
When you speak, you're literally creating vibrations in the air, little pressure waves that are smooth and continuous. They have loudness, they have pitch, and that raw analog signal is the very first thing your phone's microphone picks up.
Now, for a computer to make any sense of that smooth wave, it has to digitize it. This happens in two main steps. First, it takes thousands of tiny little snapshots of the wave every single second. That's called sampling. Then, for each of those snapshots, it gives the loudness a number. And just like that, your voice, well, it's not a wave anymore. It's a sequence of numbers. Okay, now here is where it gets really cool. The system takes that long string of numbers and turns it into something called a spectrogram. And a spectrogram is basically a picture of your voice. Seriously. Time runs along the bottom, pitch goes up the side, and the brightest spots are the loudest parts of what you said.
And this is the most important thing to get from this first section. The AI doesn't hear your voice like you and I do. It sees it. It's basically doing image recognition on this picture of sound, looking for patterns.
So, the device has a picture of your voice. Now what? Well, this is where the brain of the operation kicks in. It starts playing this incredibly complex game of probabilities to figure out what you actually said.
This whole thing is basically a two-part process. First up, you've got automatic speech recognition, or ASR. The AI slices up that spectrogram into tiny little chunks to find phonemes. Those are the smallest units of sound in a language, like the sh in show. But just hearing sounds isn't enough. That's where part two comes in, natural language processing, or NLP. This is the language model that gives it all context, figuring out what you actually meant to say.
And this right here is the absolute perfect example of why you need both parts working together. The acoustic model, the ASR, it just hears the sounds I scream. Phonetically, they're the same. But the language model, the NLP, is smart enough to look at the words around it. If you said, I want a scoop of, it knows there's like a 99.9% chance you meant ice cream, not I scream. And it fixes it.
What's so clever here is that the AI is really trying to figure out your goal. We call the phrase you say an utterance. So you could say, what time is it? Or what's the hour? Or even, hey, you got the time? Those are all totally different utterances, but the AI is smart enough to map all of them to one single intent, get the current time for the user.
Okay, so if this system is so brilliant, why does it still fail so often? Why does Alexa or Siri sometimes get your request completely hilariously wrong? Well, the system is far from perfect, and there are some really clear reasons why.
Turns out, the biggest hurdles are things that we humans handle pretty easily. Accents and different dialects, that's a huge one. Then you've got what's called the cocktail party problem, where the AI just can't pick your voice out from a crowd. Even simple background noise like an AC unit can mess up that spectrogram. And of course, regional slang. If it wasn't in the training data, the AI has no idea what arvo means. This is a classic example, and it really gets to the heart of why your smart speaker mishears you sometimes. Accents are genuinely hard for these systems. The sound patterns for how a British person says water are really different from the American version. So if the AI was mostly trained on American English, it's going to struggle to match those unfamiliar sounds, and it'll probably make a mistake.
And it all comes back to this one crucial takeaway. The AI is only as smart as the data it's been fed. Our attentive friend is trying its best, but if it hasn't heard your specific accent very often, it's basically forced to guess based on the patterns it does know. And, well, sometimes that guess is just plain wrong.
But here's the good news. The story doesn't end there, with your phone getting confused. The whole system is designed to get better over time. And, well, you're actually a huge part of that improvement. Remember our attentive friend analogy? Well, that friend is always listening and always learning.
Every single time you talk to your device, whether it works or not, you're giving it another piece of data. The system starts to learn the specific patterns of your voice, your accent, and the unique way you ask for things.
And that, honestly, is the most empowering part of all of this. You're not just a user of this technology, you are an active participant in training it. Every single voice command you give makes the entire system just a little bit smarter, helping it get more accurate for you and for everyone else.
So this all leaves us with a pretty fascinating thought to end on. As our devices get better and better at listening to us, what should we be teaching them to hear? The more seamless this bridge between us and our machines becomes, the more we have to think about what the future of our conversations with technology is really going to look like.